Now I'll walk you through the whole protocol. For the solution preparation part, I think it's already very straightforward on the written SOP. But there's still 2 points that I want to remind you guys, so it is easier and faster for you guys to make the solutions. Firstly, I would suggest let's use a volumetric flask to measure the solvent first. Then we can know how many solvent we should use in order to make the solution, and that will be easier and to make the solution and with higher accuracy. Secondly, I would say let's leave some volume space for the pH adjustment later, because the solvent we use could also help us to adjust the pH, because the water has the pH around 7, which could also help us lower or raise the pH. And in this case, we should use ammonium hydroxide or sodium hydroxide to raise the pH, or use the sulfuric acid to lower the pH value. But make sure do not use the hydrochloric acid. And we could observe the flash A. When we see there's a radical symbol like hat on it, it means it's settled down and we could do any pH adjustment then. Now I just measure the amount of OPD I want and pour it into the volumetric flask and rinse it with the solvent. This step could help us avoid or minimize the reagent loss, so make sure to do it. And then fill it, but make sure to be below the line, because the next step is to degas the solution before we add PFAS in it. But for adding PFAS in it, we still need some solvent to rinse it from the weighing paper. So we want to leave some volume space for rinsing the PFAS later. And then we parafume the top of the flask and mildly and quickly sonicate the solution. Make sure it is not very obviously bubbling. And we could also tell that there's no solid in it, it's fully dissolved. Then it's good for the degas step. Now I'm parafuming it, but you could parafume it earlier. But make sure it is parafumed during degas. And I also use some foil to avoid the light, because the solution is a little bit light sensitive, so make sure to foil it well. And we want to keep the least contact with air, so I'll loosely perfume it, but please leave a loose opening because we're blowing the argon gas in it, so make sure the pressure in the flask could be balanced so it will not blow. We won't want it to blow too fast or too slow. Maybe 1 bubble per second, that kind of speed would be good. This will be a way too strong, so I am adjusting it. I'm trying to turn it down. And now we can see this blowing speed will be good. And then I will foil it to avoid the light contact. And make sure it is foiled very well. And now I will perfume it very loosely. This step could minimize the contact of the solution with air, because we really don't want it to get oxidized by getting contact with the air in the environment. And then we could start with grinding the electrodes. I would suggest to making the OPD solution and get it set up for degassing first, because we're doing multiple electrodes at once. So we need to scale up the electropolymerization solution, which would take longer time than 50 minutes. I will usually do about 30 minutes. So during this half hour, it is enough for us to deal with the electrodes. So this could get our experiment done more efficiently. Because I need 3 electrodes, but I don't find very efficient to grinding them 3 together, because I cannot make sure they're polished very well if I polish like 3 of them together. So I polish 1 at first and then 2 together while we're grinding 2, to make sure we take off the rubber so they could get close while we're grinding it. That could help us polish it better. When polishing the electrode, moving it in a figure 8 motion could help us polish it very efficiently. If you feel a very consistent resistance, then we could add some water. We grind each electrode for 5 minutes. When the timer is up, then we take it to rinse with pure water and sonicate with pure water for about 20 minutes. When there's only a few minutes for the degas solution to finish, then we could start measure the PFAS, and when the solution is ready, then we take it to mix it with the PFAS we measured. This step is pretty similar or same as the step we're mixing the OPD with solvent. We pour it into the flask and rinse it with some solvent. This time we'll make sure we fill it up to the line. The sonication of the solution with PFAS will definitely make sure to sonicate it less than 30 seconds and to make sure there's no bubble, because it will help the PFAS to aggregate in the solution on the top. Then fill it up to the line. Then take it for sonication. Let's make sure it is not bubbling and is fully dissolved. After this step, we put it into the fridge, back into the lab, and do the contour and reference electrode preparation. For the contour electrode, we'll rinse it with water and dry it with chem wipe, and then ignite the contour electrode with fire to make sure the glass part does not touch the fire, or it will be very dangerous. When we observe the wire change the color, it means the electrode is ready and we should turn the fire off and get it back. To prepare the reference electrode, we rinse it with pure water and wipe it with chem wipe, and then put it on the plastic cell with the contour electrode. And then we take our electropolymerization solution with OPD and PFAS. Because we're not making exactly 5 ml of the solution that we need each time, so I used a volumetric flask to measure how much is 5 ml of liquid in the cell, and I draw a line on it so we could get close to 5 ml when we try to pour the solution in it and use it in the cell. And another important point is we could observe the solution. If it turns yellow, then it means the OPD get oxidized in it, and it is not very useful for our experiment. But we could see this is very transparent and it does not change color. The last step for our setup is to connect the wire with the electrodes. We usually connect the reference first, and there's no preference or requirement for the working or counter electrode which to connect first, but maybe always to connect the reference electrode first. And we should make sure it does not touch the bottom or the edge of or another electrode, and make sure they connect well. If we still not very satisfied with, like, we could see the working electrode still a little bit touching the edge, then we could move it and do some little adjustment to make sure they're in a good place. And now they look like they're not touching each other, they're not touching the bottom or the edge. Now it's very good. And then we open the CH instrument software. Click the little T for setup. We choose OCPT first, and we give it for 60 seconds. And then click OK. And make sure to click the little triangle here to let it run. This could happen, but it's not a big problem. We could restart our computer and the instrument, and that could help us solve the problem. And then I just restarted and choose OCPT and click OK, give it 60 seconds, and OK, and let it go. And now we could observe a straight line. It is usually around 0. Maybe sometimes it will be higher, sometimes it will be lower. Then we let it finish. And then we click the bottom to see how it looks like, and find the potential that the center of the graph corresponds to. And then we click the big T again to choose CV, click OK, and we enter the potential corresponding to the center of the graph here as the initial voltage, and the height as 1, and this is the parameter written in the region SOP. And then click OK. Click the same black triangle to let it run. And then it will take about 15 minutes. This is the electropolymerization graph for the lowest concentration I tried. So maybe it's a little bit flat, but we would always observe there's two broad peaks At least it will not only be some sharp peaks. The CV graph kind of reflects that maybe our electropolymerization is good, and then later we'll see tell from the signal from DPV. And this is for the electropolymerization experiment for our second electrode. We keep the first one on the cell, and also make sure to switch the solution every time for each electrode. And we also switch the wire to connect to the second electrode. And also make sure they're not touching each other, they're not touching the bottom or the edge, and they're connected well. Make sure we save the first CV graph. And make sure we switch the electrode. Sometimes I will forget it. And click the little black triangle to let it run. For the third electrode, we'll repeat what we did for the first and the second one. And then the next step is to do the template removal. We'll set up on the magnetic stirrer. Let's pour about 25 ml of the 1:1 methanol and pure water solution and put a stir bar in it. We take 3 electrodes together to rinse them with pure water, but make sure we should take a waste beaker to collect the PFAS waste because we don't want to dispose it into the drain. That would be very harmful. We'll rinse the PFAS waste in the waste beaker for the first rinse. After that, it is okay to dispose the rinse water into the sink. For the rinse before template removal, please do not dry it with nitrogen gas. And we just take it to set up for the template removal step. In this step, it's better to make sure they're at the same height and they're definitely not touching the stir bar. The stir bar is like in the maybe middle or similar distance from each electrode. Like it's not getting close to one of them, but very far to the rest of them. So we could make sure that their template removed equally. When we're satisfied with the setup, we turn the stirring plate on. Timer for 20 minutes. While we're waiting for the template removal step, let's clean the reference and counter electrode. We take them out of the solution used and rinse them in the waste beaker. with the pure water to clean the solution we used before. And we wipe it with the cam wipe. And we will put the reference electrode back because we want to keep it wet. But for the counter electrode, we could just hang it on the plastic cell for the later use. Then to make the PFAS standard solution, we'll measure the amount of PFAS we want. To make 5 ml of PFAS standard solution, we're going to measure 0.0125 gram to make 5 millimole PFAS solution. And then use the Hampton syringe to take 50 microliter from the 5 millimole PFAS solution to dilute it to 10 millimole. Then we could have the 25 micromolar standard PFAS solution. This step is also very similar to the previous steps, that we pour it into the flask and rinse the rest of it on the weighing paper with the solvent. The solvent we use here is pure water. And then we'll fill it up to the line. Because we're making 5 ml, so that is not a very big volume, so make sure while we're rinsing it, we do not miss the line. Like fill it higher than the line. Then we sonicate it quickly to make sure all the solid is fully dissolved in our solvent. When 20 minutes for the template removal is up, we take all the electrodes and rinse them with pure water and collect the waste water in the waste beaker. And this time we will dry it with nitrogen and then put them back on the plastic cell. We will rinse the whole electrode and also blow the whole electrode with nitrogen, but make sure we just like horizontally blow it, because we don't want to just directly blow on the end of electrode, which might break our electropolymerization on the electrodes. After we set up for the electrochemical measurement, then we should take a 25 ml volumetric flask to measure the phosphoric buffer solution. Please use a volumetric flask to measure, because we want exactly 25 ml in order to control the PFAS we added. So we have the solution, so we have the concentration of solution that we designed before. This time it's in the 25 ml beaker, so it is actually easier to adjust the electrode because there's more space for them. But we will also make sure they're like not touching each other, not touching the edge or bottom, and they connect well. Also click the big T and select DPV and enter the parameters. After we make sure everything is connected well, and then we click the little black triangle and let it run. This will not take 15 minutes. It will be very fast. And then we will click File and save it as, we'll give it a name with the date and maybe concentration, and we'll also mark it as electro 1, electro 2. And then we'll switch the connection with the second electrode and make sure everything is well in the beaker. We will also make sure the previous document is saved, and then we click the triangle to let it run. We could click the bottom to see how it looks like, and then save it, name it, and then switch to the next electrode. And now I will inject some PFAS standard solution that we diluted before. I didn't include the dilution of the PFAS standard solution in this video, but make sure to take 50 microliter of it and dilute it in the 10 ml volumetric flask. So we take 10 microliter first and inject it in our buffer solution, and then we will stir it for 60 seconds and let it settle down for 30 seconds, and we will make sure we switch the electrode to the first electrode every time, and we'll also make sure our previous document is saved, and then we'll click run. We should usually set a timer for the stirring and the settle time, but we could also use during that time we could use the acetone to rinse and clean our syringe before next injection. For the use of syringe, we should make sure that there's no bubble in it, so it is cleaned well. But for better use of the syringe, please watch the video that's included in the written SOP. And then switch it to the first electrode while it's still settling down. Then let it run after we make sure we save the previous document. Then save it and make sure we switch to the next electrode. Don't forget this step. The next steps are pretty or basically same. Just injected maybe different volume of PFAS. Just make sure we will clean the Hampton syringe very well with acetone for the next use of the syringe.